Hello students, good evening. Welcome to the second session of this electrostatic potential and capacitor topic. இன்னைக்கு என்னன்னா we'll start with the idea of electric potential. Already first session நம்ம potential energy பத்தி we have discussed about it. Okay, how do we calculate the potential energy of a charge combination? So if you have a pair of point charges, the combination of the two charges for a pair, potential energy will be estimated as what? K q1 q2 by r if they are at a separation r. Okay, this potential energy is by considering the reference as what? At infinite separation. இதுக்கு நம்ம எடுத்த reference என்னது? At infinite separation. If the charges are at infinite separation, then the potential energy of the combination is zero. அதுதான் நம்ம எடுத்த reference. Based on that reference, when the two charges are separated by distance r, and the combination of the potential energy is K q1 q2 by r. Okay va? Now today we will begin the discussion with the idea of electric potential, and is ரொம்ப important because past year questions பாத்தீங்கன்னா we would have got like from this chapter almost or 40% of the times questions would have come directly or indirectly related to the electric potential. Okay, so what is this electric potential? So electric potential, just like electric field, electric field already discussed பண்ணிருக்கோம். Electric field மாதிரி it's a space function and so means what? This is defined at a point in a space. So electric potential is not a property of an object. இது ஒரு object property கிடையாது. It's what? It's a space function like field மாதிரி. Like you will say what is the electric field at the point 1 comma 1 comma 2 அப்படி. So like here at every point in space, right, we can talk about electric potential. Okay, so electric potential is represented by the symbol V. Generally the electric field is represented by the symbol capital E, and the electric potential will be represented by the symbol capital V. Okay, but how do we define this electric potential concept? Now mark a point in the space. Take a point in the space. Okay, if we bring a charge q என்ன தெரியுமா? So we'll generally call it as what? Test charge. So if you bring a charge q to a particular place, if the potential energy of the charge is u, when you bring it to the point, the potential energy of the charge is becoming what? U. Then the electric potential at the location, right, will be defined as u by q. So anyway, what is it? It is like the potential energy per unit charge. So space la you take a point. Okay, we are bringing or test charge எடுத்துட்டு we are placing it there. Place பண்ணா the test charge will get a potential energy, right? Let us say the potential energy oda value u னு வெச்சுக்கோங்க. Then the potential energy of the test charge divided by the charge value, அதோட charge value divide பண்ணா we will get what? The electric potential at the location. Okay, so அதுதான் V. இப்போ பாருங்க, the relation between potential energy of the charge and electric potential எப்படி வரும்? V is equal to what? U divided by Q. Cross multiply பண்ணா V into Q is equal to U. Means, say for example, at a point in the space, electric potential V னு வெச்சுக்கோங்க. We'll bring a charge to the point. Upon the charge, the potential energy எவ்வளவு ஆகும்? It will be what? Q times V. The charge times the electric potential. நீங்க close observe பண்ணா this is similar to the way we define this electric field concept. Like, if you bring a charge to a particular place, let us say the field at a point is E, then force acting on the charge is given by what? Q into E dana. Same அந்த மாதிரி இங்க என்னது, the potential energy of the charge will be equal to what? Q times V. So எப்படி அந்த electric field வருதோ as it is அதோட analogous మనం வெச்சுக்கலாம். So electric field ஓட analogous என்னது? Potential. Field is giving rise to force. Potential is giving rise to what? Potential energy. The potential function in the space is giving rise to what? Potential energy. Okay va? So இப்படி தான் the definition of the electric potential is taken. So how do you define the electric potential? If you mark a point in the space, at that particular point, potential energy per unit charge, நீங்க ஒரு test charge எடுத்துட்டு we'll place it there னு வெச்சுக்கோங்க. Then the potential energy of the test charge divided by the test charge ஓட value. அப்படி பண்ணா we will get what? The electric potential at the location. Remember this, what is the electric potential? It is a state function. Means the electric potential at the location will exist even without a charge actually present there. When we test charge and get it polanna, it does not mean that anga potential will be there. Okay, whether we go and keep the test charge there or not, electric potential will be there at that point. Okay, now the question is, whenever we see a new physical quantity, right? I told you that we have to ask two questions. And we should be asking about what is the SI unit of that particular physical quantity, and what is the dimensional formula, because these are two very prominent things. Okay, what is the SI unit of electric potential and what is the dimensional formula? Okay, so namakita ore formula irukku, the potential energy acquired by that charged particle will be equal to what? Q times V. Okay, so idhilandi we should try and get what is the SI unit as well as the dimensional formula. Paranga, V electric potential into charge is what? Coulomb, is equal to potential energy SI unit is what? Joule. It will be what? Joule per coulomb. In fact, this is named in honor of the scientist as volt. So what is 1 volt means? 1 volt means it will be 1 joule per coulomb. Okay, and what about the dimensional formula? Dimensional formula enna varum parunga, V charge. What is the dimensional formula? I into T. Potential energy is energy rate. Energy means what? ml square T power minus 2 dana. Energy dimensional formula enna? ml square T power minus 2. So dimensional formula for the potential is equal to what? ml square T power minus 2 divided by, அப்படியே அந்த பக்கம் it will go to the denominator, I into T. பாருங்க, ml square T power minus 3 ஆயிடும். T power minus 3 I power minus 1. What is this? Dimensional formula for the electric potential. Okay, so what is the SI unit? Volt. What is 1 volt? Joule per coulomb. And what is the dimensional formula? ml square T power minus 3 I power minus 1. Okay va? So this is about the definition of the electric potential. Okay, but question enna, how this electric potential is coming? Ipo nama enna sollirukom, you take any point in the space, at that point there will be electric potential. Okay, but how is this potential coming? Inga eppadi varudhu? Just like field is created by the electric charges dana, and the location or surrounding la whatever the charges that are there, they will produce the electric field. Inge appadida, like whatever the surrounding charges, right, they will produce this electric potential function. The surrounding charges will be producing electric potential function. Okay, how we will try to understand it? First enna theriyuma, we will look at what is the electric potential due to a point charge. Okay, or point charge nala what is the electric potential that will be developed. Okay, adukku enna theriyuma, we will start with a point charge capital Q. Okay, adoda location landu mark a point P. The point charge Q nam eduthirukkom, capital Q. Okay, so what is this capital Q? It is a point charge. Okay va, angalandu we are marking a point P at a distance R. Charge landu we are marking a point P at distance R. Okay, now we want to find what is the potential here. What is the potential created by the charge at this location? Okay, adukku enna theriyuma, we will bring a test charge. அங்க ஒரு test charge எடுத்துட்டு போலாம். So எடுத்துட்டு போனா what is it? The test charge we are going and keeping there. Okay. Now what is the potential energy of this combination? The combination of the potential energy value என்ன already அந்த formula நம்ம கிட்ட இருக்கா. என்னது? K into capital Q small q by r. இதுதானா? இந்த potential energy formula modulus வராது. Okay. As it is. If the charge is positive means we have to put positive. Charge is negative means we have to put negative. Okay. So இது என்னது? Potential energy formula. இது already நம்ம கிட்ட இருக்கா. Potential energy formula. Okay. Now based on the definition of electric potential, இப்போதான் நம்ம பார்த்திருக்கோம். What is it? The potential energy of the charge will be given by what? Q times electric potential at the location. இது எங்கல இருந்து வருது? This is coming from the definition of potential. Potential at definition வந்து இந்த relation வருது. If you are keeping the test charge at a location means the potential energy of the test charge will be equal to what? Charge times the electric potential at the location. Okay. அப்படியே நம்ம இந்த ரெண்டு வேல்யூஸ் ஈக்குவேட் பண்ணலாம். ஈக்குவேட் பண்ணா என்ன வரும்? small q cancel ஆயிடும். What is it that we are getting? V is equal to what? kq by r. அவ்வளவுதான். So the test charge ஓட வேல்யூ cancel ஆயிடும். The potential is developed by the point charge. The point charge capital Q, right? At a distance r from it. What is the electric potential it is developing? Kq by r. Okay. இதுல இருந்து என்ன தெரியுமா? We'll have some important conclusions. இப்போ பாருங்க, if the charge is a positive charge னு வெச்சுக்கோங்க. The charge capital Q we are taking is a positive charge. Then potential will be what? V oda value என்னது? It will be what? If the Q is positive means V will be positive. So potential will be positive if it is developed by a positive charge. Okay. So positive charge will develop positive potential. அப்படி இல்லாம if the Q is a negative அண்ணா what is going to happen? இங்க negative substitute பண்ணா என்ன வரும்? மத்ததெல்லாம் positive தானா? K is a positive constant. R அப்படிதான் distance. Means what? The potential will be negative due to negative charges. Okay, so potential developed by the positive charge will be positive. Potential developed by the negative charge will be negative. Okay. Ingonnu paranga, if you look at the relation in terms of R, if you look at the relation in terms of R, inga paranga, if the R is decreasing means in the total value what will be what? The total value of V will be increasing. Edhanala, because R is in the denominator, right? Denominator நம்ம கம்மி பண்ணா and the expression of the total value will be increasing. Okay. Means what? Decreasing R means we go closer and closer to the charge. And the charge கிட்ட போற மாதிரி. So if we decrease the R means we are going on closer to the charge. அப்ப என்ன ஆகும் தெரியுமா? If the value is increasing means what? இங்க பாருங்க, value is increasing means if the potential is positive means what? It becomes more positive. அப்படிதானா? நம்ம ஒரு பாசிட்டிவ் சார்ஜ் கிட்ட போனா what is going to happen? The potential is going to become more and more positive. இன்னொரு பாசிபிலிட்டி என்ன? If we go closer to a negative charge, அங்கேயும் அப்படிதான், the potential value will increase but இதனது negative. So which means what? The potential is going to become more and more negative. So if we go closer to the positive charge, right, what is going to happen? The potential of the value will become what? More and more positive. If you are going closer to the negative charge, then what is going to happen? The potential is going to become more and more negative. Okay. So let us say we have an arrangement. Left side, let's say there is a positive charge. Right side, there is a negative charge. Now on the left side and the right side, what is going to happen? We are going away from the positive charge. Positive charge, we are going away. அப்படியே we are going closer to negative charge. Then what is going to happen? The potential is going to become what? More and more negative. In other words, we can say the potential value is going to decrease. என்ன சொல்லலாம்? The potential value is going to decrease. Okay. So we'll just look at these possible cases. என்னது? we can have the potential measured with respect to a positive charge or with respect to negative charge. Okay, potential developed by the positive charge will be positive, potential developed by the negative charge will be negative. Okay, if you grow closer to a positive charge, the potential value will be increasing. If you go closer to a positive charge, potential value will be increasing. If we are approaching a positive charge, potential will become what? More positive. If we approach a negative charge, potential becomes what? More negative. More negative. What is it? This is like decreasing only, right? More positive means this is increasing. Okay. If we go away from the positive charge, then also potential will be decreasing. If you go away from positive charge, the potential will be decreasing. If you go away from negative charge, potential is going to be increasing. Because negative charge kita approach panna, potential is becoming more and more negative, means actually it is decreasing. So if you are moving in the opposite direction, means potential will be what? Increasing. Okay, wow. So this is how the potential is going to change based on our movement. Okay, positive charge kita pona, then the potential will be what? Increasing. Moving away from positive charge means moving close to positive charge, potential increases. Moving away from positive charge, potential decreases. Negative charge opposite. Moving closer to negative charge, potential decreases. Moving away from negative charge, potential will be increasing. Okay, wow. So this is about how the electric 1 by 4 pi epsilon naught, if it is a vacuum or free space or air. If you have some other medium, means K will be equal to what? 1 by 4 pi epsilon. If the medium is not air, right, or vacuum, then what we'll have? K will be equal to 1 by 4 pi epsilon. What is epsilon? Permittivity of the respective medium. Okay, so this is what we have to look at the electric potential due to a point charge. Okay, now same நம்ம அந்த electric field discuss பண்ணிருக்கோம். If you mark a point in space, அதுக்கு surroundingல there are many charges ன்னு வெச்சுக்கோங்க, then we'll talk about the cumulative electric field அங்க, because each charge will produce electric field. அதனால என்ன ஆகும்? The point you are marking, right, அங்க we'll have many electric field vectors. So அப்படியே நம்ம அந்த electric field vectors எல்லாம் எடுத்துட்டு we have to add it. That is the concept discussed there. அங்க என்ன தெரியுமா? When we are adding electric fields, we have to be careful. ஏன்னா electric field is a vector quantity. Electric field என்னது? It's a vector quantity. But இது என்னது பாருங்க? Electric potential at a point due to many charges in the surrounding or the vicinity. Okay, இப்போ நம்ம ஒரு லொகேஷன் எடுத்து வச்சுக்கோங்க, அதுக்கு சரௌண்டிங்ல there are many charges. Maybe நம்ம இங்க ரெப்ரசென்ட் பண்ணது என்ன? 4 charges. You can have many charges also. Okay, so பாருங்க, the distance from this is r1, அந்த மாதிரி here is r2, here it is r3, here it is r4. v1 will be equal to what? kq1 by r1. v2 will be equal to what? kq2 by r2. v3 will be equal to what? kq3 by r3. v4 will be equal to what? kq4 by r4. தனித்தனியா ஒரு charge அங்க potential develop பண்ணும். If you want to know what is the total potential at the location, it will be simply what? Sum of all the potentials. அவ்வளவுதான். இதுல நமக்கு இன்னொரு கம்ஃபர்ட் என்ன தெரியுமா? Electric potential is a scalar quantity. இது வெக்டர் கிடையாது, it's a scalar quantity. Why? இங்க பாருங்க, the relation between electric potential and the potential energy. What is the formula we have? Q times V is equal to U. அதுதானா? Q times V is equal to what? U. So charge is what? Scalar. Potential energy is scalar da. Means what? This electric potential, right? It's a scalar quantity. இது ஒரு வெக்டர் கிடையாது. Means we can simply add them like numbers. இப்போ பாருங்க, let's say this is coming like ஒரு 4 volt ன்னு எடுத்துக்கோங்க. அந்த மாதிரி this is coming like minus 2 volt. Because the potential developed by a charge can be positive or it can be negative also. Idanadi potential because of the third charge may be 1 volt. Potential because of fourth charge, take it as 3 volt. You want to find the total potential at the location, means how the value is going to come? simply we have to add all these values. So V1 plus V2 plus V3 plus V4, what is it? 4 minus 2 plus 1 plus 3, so what is 4 minus 2? 2 volt. 2 plus 1 plus 3, 6 volt. It's going to be very straightforward. Electric field மாதிரிங்க vector relation அதெல்லாம் வராது. ஏன்னா because it is what? It is a operation involving scalar. அப்படியே நம்ம numbers add பண்ண subtract பண்ண மாதிரி தான். Okay, so this is how we are going to find the cumulative potential at a point. Okay, so ஒரு point நம்ம எடுத்தோம்னு வெச்சுக்கோங்க. If there are many charges surrounding, என்ன பண்ணணும்? We should just calculate a potential developed by each of the charges. அப்படியே அந்த எல்லா potential value நம்ம add பண்ணணும். Okay, add பண்ணா we will get what? The cumulative potential or the total potential. Okay, in addition என்னன்னா, this is like adding simple numbers தான், because electric potential is a scalar quantity. பாருங்க, நம்ம question பார்க்கலாம். 4 charges q minus 2q 3q அந்த மாதிரி minus 4q are kept at the corners of a square. Side length எவ்வளவு L. So we are keeping these 4 charges at the corners of a square. என்ன தெரியுமா? We just try to represent the charge arrangement in the diagrammatic manner. பாருங்க, q அப்புறம் minus 2q 3q and minus 4q. இதுதானா? What is the side length of the square L? என்ன கேக்குறாங்க? What is the electric potential at the center? Center கிட்ட, what is the center means what? The center of the square. Okay, the square oda center கிட்ட, what is the electric potential? பாருங்க, for each charge, right, we should know what is the distance from the center to that particular corner. In a square, what is the diagonal? Root 2L. If L is the side length of the square, what is the diagonal? Root 2L. The distance from center to any corner will be equal to half the diagonal. எப்படி வரும் பாருங்க, the diagonal, right, each of the diagonals will be bisecting. Square என்ன தெரியுமா? What is the property of the square? The diagonals bisect. வெறும் bisect மட்டும் கிடையாது, they will bisect perpendicularly also. Okay, but நமக்கு அந்த ப்ராப்பர்ட்டி ஃபுல்லாவே தேவையில்லை. What is it? They will bisect means what? The total diagonal is root 2L means this part center length. If you want to measure the distance to any corner, right, what is it? Half of the diagonal means diagonal is root 2L divided by 2. இங்க பாருங்க, 2 நம்ம எப்படி எழுதலாம்? root 2 into root 2. அப்போ root 2 cancel ஆயிடும். What is it? L by root 2. அதுதானா? So this is our D, distance from any corner to the center of the square. என்னது? What is it? L by root 2. Okay வா? So if you remember this result means, அதுக்கப்புறம் the approach will be very simple only. So அடுத்த step என்ன? We should calculate what is the potential because of each charge. பாருங்க, potential because of charge q, kq by d. d நம்ம ஃபைனலா சப்ஸ்டிட்யூட் பண்ணலாம். Okay, potential because of minus 2q, k into minus 2q by d. Potential because of 3q, k into 3q by d. எல்லா சார்ஜஸ்ல இருந்து what is the distance to center? Same value, right, d, which is our L by root 2. d நம்ம finally substitute பண்ணலாம். What is the potential because of minus 4q? k into minus 4q by d. When we say total potential, right, என்ன பண்ணணும்? அப்படியே எல்லா வேல்யூஸ் நம்ம ஆட் பண்ணணும். Potential because of q, potential because of minus 2q, potential because of 3q, அந்த மாதிரி potential because of minus 4q. இங்க பாருங்க, ஆட் பண்ண என்ன ஆகும்? இது என்னது? பாசிட்டிவ் பாசிட்டிவ், kq by d 3kq by d, டோட்டல் என்ன வரும்? 4kq by d. அப்படியே இந்த 4kq by d இந்த minus 4kq by d cancel ஆயிடும். ரிமைனிங் என்ன தெரியுமா? வெறும் இந்த மாதிரி மட்டும். What is the remaining value? minus 2kq by d. அவ்வளவுதான். But in the d நமக்கு it should not be representing the final answer, right? d க்கு பதிலா நம்ம என்ன சப்ஸ்டிட்யூட் பண்ணணும்? L by root 2 சப்ஸ்டிட்யூட் பண்ணணும். சப்ஸ்டிட்யூட் பண்ணா root 2 அப்படியே மேலே போயிடும். What is it? minus 2 root 2 KQ by L. This is what is the total potential at the center. We were just looking at what is the potential due to each of these charges. Apdiye we are looking at the relation between the side length and the distance from center of the square to corner. Okay, adilende we are able to find out what is the net electric potential in the center. Okay va? So this is the kind of questions we have. Even past year questions lo pathina, we got, if there is a question on this model, right, cumulative potential ku mele if there is a question means it will be like this only. They will give us some charge arrangement. இப்போ இங்க பாருங்க specific values கொடுத்திருக்காங்க. இதுல என்ன, சோ இதுக்கு முன்னாடி நம்ம சால்வ் பண்ண ப்ராப்ளம்ல we have only parameters q minus 2q அப்படி. இங்க என்ன தெரியுமா, specific values கொடுத்திருக்காங்க. பாருங்க 3 point charges. 1 micro, mu means what, micro, 1 microcoulomb minus 2 microcoulomb and 3 microcoulombs are placed at 1, 0, 0. 1, 0, 0 anu theriyuma, it is placed on the x axis mele iruka. 0, 2, 0 means it is on the y axis. Okay, அடுத்து பாருங்க 0, 0, 3 means it is on the z axis. Okay, ஒரு சார்ஜ் எங்க இருக்கா, x axis மேல, இன்னொரு சார்ஜ் y axis மேல, இன்னொரு சார்ஜ் எங்க z axis மேல. Okay, find the electric potential at the origin. அவ்வளவுதான். So we have to find what is the electric potential at the origin. இங்க பாருங்க, இது x axis நம்ம எடுக்கலாம், y axis இது என்னது, z axis. q1 இங்க இருக்கா, q2 இங்க இருக்கா, q3 is on the z axis. Okay, இப்போ நம்ம என்ன தெரியும் பாருமா, we should look at what is the distance of the q1 from the origin. Position என்ன, 1, 0, 0, right, means this will be 1 meter. What is the distance of q2 from origin பாருங்க, what is the y coordinate value, 2 meter. That's the distance from origin to the q2. அப்படி இது பாருங்க q3 ஓட distance, புரியுதா? Now we, because of the first charge, what is it, k q1 by r1. இதெல்லாம் specific values கொடுத்திருக்காங்க, so we have to substitute. k value எவ்வளோ, 9 into 10 power 9. q1 is 1 microcoulomb. so எல்லா values நம்ம SI யூனிட்ல தான் எடுத்துறோம். Okay, so 1 into 10 power minus 6. r1, what is r1, 1 meter. so இது என்னது பாருங்க, 10 power 3 மட்டும் remaining. so 9 into 10 power 3 volt. Okay, அதுக்கு அப்புறம் v2 என்ன பாருங்க, 9 into 10 power 9. q2 எவ்வளவு, minus 2 into 10 power minus 6. negative charge divide by distance என்னது பாருங்க, 2 meters. இந்த 2 cancel ஆயிடும். what is the remaining thing, minus 9 into 10 power 3 volt. அதனது v2. okay, அதுக்கு அப்புறம் v3 is what, k into q3 by r3 தானா, which is 9 into 10 power 9. q3 எவ்வளவு, divide by r3 means what, 3 meters. இதுல அப்படியே 3 cancel ஆயிடும். so 9 into 10 power 3 volt. இதென்ன பாருங்க, v1 is what, 9 into 10 power 3. v2 எவ்வளவு, minus 9 into 10 power 3. v3 will be 9 into 10 power 3. so total potential தான் நமக்கு வேணும், which is what, v1 v2 அப்படியே cancel ஆயிடும். ஏன்னா v1 is what, 9 into 10 power 3, v2 is what, minus 9 into 10 power 3. so வெறும் அந்த v3 value மட்டும் it will be remaining. what is it, totally 9 into 10 power 3 volt. இல்லனா இது நம்ம இன்னொரு மாதிரி எழுதலாம் தெரியுமா, 10 power 3 volt means we can write it as what, kilovolt. so 9 kV, 9 kilovolt. okay, ஓகேவா? அடுத்த கொஸ்டின் பாருங்க. Find out the points on the line joining two charges. என்னன்னா -q ஒரு சார்ஜ், இன்னொன்னு -3q. So find out the points on the line joining the two charges kept at a distance of 1 meter where the electric potential oda value is 0. Okay, already electric field case la நம்ம ஒரு பாயிண்ட் சொல்லிருக்கோம். என்னது? If electric field at a point is 0, we'll call that point as what? Null point and solite. Okay, if the electric field at a point is 0, we call it as what? Null point. Okay, inga we don't call it by a specific name, but this is also an important type of question. What is it? Where the electric potential can become 0. inga enna theriyuma? Electric potential in a region can become 0. ஒரு region or space la you want to know whether the electric potential becomes 0 or not. adukku enna theriyuma? The charge arrangement should have both positive charges as well as negative charge. அப்பதான் அந்த electric potential 0 ஆகிறதுக்கு there will be a chance. ஏன் தெரியுமா? if எல்லா இருக்கிற charges எல்லாம் பாசிட்டிவ் வெச்சுக்கோங்க, then each and every charge will produce only positive potential தானா, which means அந்த values நம்ம ஆட் பண்ணா 0 ஆகிறதுக்கு there will be no chance. அந்த மாதிரி if in a region there are only negative charge வெச்சுக்கோங்க, then what is going to happen? the electric potentials எல்லாம் நம்ம ஆட் பண்ணா full எல்லா நெகட்டிவ் வேல்யூஸ் தானா, ஆட் பண்ண என்ன வரும்? total value also is going to become negative only. so அதனால the potential cannot become 0. when the potential will become 0 if we are having positive charges and the மாதிரி negative charges. அப்ப என்ன ஆகும் தெரியுமா? the positive charges will produce positive potential and negative charges will produce negative potential. then there will be a chance for them to cancel. and if the positive potential value is matching the negative potential value, matching means the values will be same, one is positive other is negative, add panna enna varum? 0 dana. so that is how we can get the total potential to be 0. okay, ipo take for example angal kudutharna there is a plus q and the madri there is a minus q. now there can be many points in the space where the potential can actually become 0. there can be many points in the space where the potential can actually become 0. but இவங்க என்ன கேக்குறாங்க? the points on the line joining the two charges. in the line க்கு மேல the points on the line joining the two charges. இங்க பாருங்க, if look at இது என்ன தெரியுமா? like நம்ம அந்த electric field நம்ம டிஸ்கஸ் பண்ணிருக்கோம். அப்படியே இந்த line joining the charges நம்ம split பண்ணலாம். region A, region B, region C. இந்த பக்கம் என்னது? region A, நடுவுல region B, ரைட் சைடு என்ன? region C. ஓகே, இப்ப பாருங்க, if we are in the region C ன்னு வெச்சுக்கோங்க. if we are in the region C, okay, let us say the distance between the two charges is D. in the -3q ல இருந்து we have a point marked at a distance R. so இங்க potential value என்ன வரும்? because of -3q, k into -3q by R. what will be the potential because of q in the point? what is the potential because of q? k into q by இங்கல இருந்து distance என்னது? d plus R or R plus d. இப்போ இந்த ரெண்டு வேல்யூஸ் நீங்க கம்பேர் பண்ணுங்க. இதுல என்ன தெரியுமா? நியூமரேட்டர்ல we have a multiplier 3. இங்க அந்த 3 கிடையாது. means what? here numerator is high. okay, denominator compare பண்ணி பாருங்க, அங்க என்னது? R. here R plus D means denominator is low. remember, when numerator is high and denominator is low, right? what does it mean? and the fraction of the value will be always higher than the other fraction dana. so numerator ஜாஸ்தி, denominator is what? lesser, means that fraction value will be always higher. like இப்போ நம்ம கம்பேர் பண்ணும்போது என்ன தெரியுமா? let's say இங்க என்னது? we have 7 by 2 and 5 by 3. இப்போ இந்த ரெண்டு வேல்யூஸ் நம்ம கம்பேர் பண்ண வெச்சுக்கோங்க. then இங்க பாருங்க, numerator is higher, denominator is lesser, so this fraction value will be always higher than the other one. அப்படிதான் நம்ம fractions compare பண்ணும்போது, which means what? when we try to add both of them, right, idhula oru value anadi negative, ingonnu positive. When you try to add both of them, they cannot add up to 0. Ena the negative value idi will be always higher than the positive value. Adana they will not be able to add up to 0, which means region C oda significance enna theriyuma, that is the region which is closer to the higher value charge. Enadi the region is what, closer to the higher value charge. Ipo இந்த ரெண்டு chargesல ஒரு value என்ன plus q, இன்னொன்னு minus 3q. அதுல what is the higher value charge means minus 3q தானா, value மட்டும் நம்ம பார்க்கணும். So higher value charge means what, ஒரு charge என்னது plus q, இன்னொன்னு minus 3q. Higher value charge means minus 3q. So region C is what, side closer to higher value charge. அந்த region என்ன தெரியுமா, we will never be able to have the potential adding up to 0. அந்த regionல நமக்கு அந்த potential 0 point வராது. ஓகேவா, அது முடிஞ்சிது. So we are able to conclude that. Next என்ன தெரியுமா, we will go to the region B. We will go to the region B. Region B la we will have a chance for getting potential to be 0. எப்படி, when we are going closer to the positive charge, the potential because of positive charge will be increasing. When you are going away from the negative charge, what is going to happen, potential because of negative charge will be decreasing in the value, which means we will have a point in between somewhere. அது எங்கன்னு சொல்லிட்டு நம்ம பார்க்கணும். But somewhere there will be a point where the values will be equal but signs are opposite, right? அதனால என்ன ஆகும், when we add both of them they will add up to 0. So region B there will be a chance for the potential to become 0. அந்த மாதிரி தெரியுமா, region A also, region A you will have a point where the potential can become 0. இங்க பாருங்க, we will mark a point distance r from the plus q. So potential because of plus q எவ்வளவு, kq by r. Potential because of minus 3q என்ன தெரியுமா, k into minus 3q by r plus d. So இங்கல இருந்து என்னது, minus 3q ல இருந்து what is the distance, r plus d. இங்க பாருங்க, numerator value higher, denominator is also higher. So அதனால for a particular point, right, you may see that this value will be numerically matching with the other potential value. So we have a chance for getting the 0 potential point on the side A also. So it's a very standard result. என்ன தெரியுமா, maybe we can expect some numerical question on this, illana they can even ask some theoretical question. So if you have two charges opposite type, then on the line joining the charges, right, how many points can be there where electric potential becomes 0? எத்தனை points வரும் தெரியுமா, we'll have 2 points. One point will be on the region B குள்ள வரும், which is the segment between the two charges. இன்னொரு point எந்த பக்கம், region A. Region A ஓட significance என்ன தெரியுமா, it is the side which is closer to the lower value charge. நம்ம கொடுத்த ரெண்டு chargesல the side which is closer to the lower value charge. அந்த பக்கம் என்ன தெரியுமா, we already saw that. அந்த சைடுல என்ன, we will never get the point where the potentials will add up. So இப்போ நம்ம என்ன பண்ணணும், they are asking us find out the points ன்னு கேக்குறாங்க. So first பாருங்க, we will look at the region A la. So in the plus q la we are taking a point which is the distance r. In the D another D is 1 meter. Okay, so inga parunga, potential because of the plus q la kq by r. Potential because of minus 3q la k into minus 3q by, this is what, D is 1, right? So 1 plus r varum. Totally it should add up to 0 தானா. So இங்க பாருங்க, k into q அப்படியே நம்ம காமன் எடுக்கலாம். எடுத்தா 1 by r minus 3 by 1 plus r. This should be 0. Means what? 1 by r should be equal to 3 by 1 plus r. Cross multiply பண்ணா 1 plus r should be equal to 3r. 1 is equal to 2r. R will be what? 0.5. R oda value is 0.5. Okay, so we'll have a point where the potential is 0, which is the first point, 0.5 meters on the left side of plus q. The plus q left side la we have a point. What is the distance of the point? 0.5 meters from the plus q. Okay, இது முடிஞ்சது the case 1. இன்னொரு possibility என்ன, we can have a point where the electric potential is becoming zero in the region between the two charges, right? அங்கே ஒரு possibility இருக்கா. So அதை எப்படி calculate பண்ணது பாருங்க. So இதில் we'll mark a point P here, distance R from the charge plus Q. Plus Q we are marking a point, distance R. So அப்போ இந்த பக்கத்துல what will be the distance? The total ரெண்டு charge நடுவில் what is the total gap? 1 meter, right? So இப்போ நம்ம இது R ன்னு சொன்னா what is the remaining part going to be 1 minus R தானா? Now potential because of plus Q will be what? KQ by R. Potential because of minus 3Q will be what? K into minus 3Q by 1 minus R. ரெண்டு நம்ம add பண்ணா we should get 0, right? Which is what? KQ by R minus 3KQ by 1 minus R, that is 0. அப்படி நம்ம KQ common எடுக்கலாம். Common எடுத்தா 1 by R minus 3 by 1 minus R is equal to what? 0. So KQ is a constant, right? Which means what? The bracket உள்ள இருக்கிற term should become 0. அதுதானா? What is the bracket term inside the bracket? 1 by R minus 3 by 1 minus R is 0, which means 1 by R should be equal to what? 3 by 1 minus R. Cross multiply பண்ணா அப்படி நம்ம மேல எழுதலாம். So cross multiply பண்ணா என்ன வரும்? 1 minus R is equal to 3R. அந்த பக்கம் எடுத்துட்டு போனா 1 is equal to 4R, which means what? R is equal to 1 by 4 or 0.25 meters. So second possibility என்ன பாருங்க? 0.25 meters on the right side of plus Q. So நம்ம மென்ஷன் பண்ண பாயிண்ட்ஸ் என்ன தெரியுமா? with respect to plus Q ஒரு பாயிண்ட் என்னது? 0.5 meters on the left side of plus Q. இன்னொன்னு 0.25 meters on the right side of plus Q. Okay, so this is important. If you are having two unequal values and opposite charges, அப்படி இருந்தா then you know on the line joining the two charges எத்தனை points வரும்? which will have potential 0. 2 points will come. ஒன்னு on the region between the two charges, இன்னொன்னு என்ன? on the side which is closer to the smaller value charge. Okay, so இது நமக்கு ஞாபகம் வச்சுக்கணும். we will go to the next concept, the relation between work done and electric potential. So this is also another important one. ஏன்னா ஒரு சில past year questions they have touched upon this idea. It's a very basic idea. Even 10th standard also we will have this concept. So பாருங்க, we have a charge Q. We are trying to move it from a place where the potential is V1 to a place where the potential is V2. England we are trying to move it. We can move in any path. We can move the charge in any path. Okay. Now when you move it from here to here, obviously there will be a change in the potential energy. What is change in potential energy? Final potential energy minus initial potential energy, which is what? Q into V2 minus V1, which is Q times delta V. Delta V is called as what? Change in the potential value. Okay va? So ஒரு இடத்துல இருந்து if you are moving the charge to another place means there will be a change in potential energy, right? And change in kinetic energy may be there or may not be there. It depends. It depends on situation to situation. Sometimes we may assume that we are not giving any kinetic energy. So initial kinetic energy and final kinetic energy, we may assume it to be 0 like that. In that case, the kinetic energy change will not be there. Okay, wow. Sometimes there may be a change in kinetic energy term also. Okay. So when you are trying to move the charge from one place to other place, we are doing work. External work is done. What is the basic formula of the work energy theorem? Work energy theorem oda basic formula enna? Work done by the external forces is equal to what? Change in kinetic energy plus change in potential energy dana. What is the work done by the external force? Change in kinetic energy plus change in potential energy. Inga parunga, change in potential energy ku badala nama enna eludala? Q times delta V. Adudha. So this is the relation. When you try to move the charge from one place to another place, the work that the external force means we are also external force, right? Nama move panna, what is it? We are doing the work. The work done by the external force is equal to what? Change in kinetic energy plus change in potential energy ku badala nama enna eludala? We can write as what? Q times delta V. Okay. Idhula na sonna madri, if we assume that kinetic energy term not involved. Kinetic energy term involve agalana, then what is it going to be? Under that assumption, if kinetic energy is not involved in vechkonga, appo enna agum, the work done by the external force and the kinetic energy term varadu, and the term involve agalana, the work done by external force will be simply equal to what? Q times delta V. Okay, adu eppo varum? When we make that assumption that kinetic energy is not involved. Like, you know, for a question statements partha, they will say a charge is moved from one place to another place. They will not even mention about the velocities. Apdi mention pannalanna enna theriyuma, we have to assume that the charge is initially static, and madri final also the charge is static. And the assumption enna theriyuma, the kinetic energy term varadu. Appo we can use this relation. What is it? Work done by the external force is equal to what? Change in the potential energy mattum varum, which is what? Q times of delta V, which is equal to what? Q times of delta V. Okay va? So paranga idla we have some questions. In fact, this is a question that has come in the one of the previous years. Okay, paranga, a point charge plus Q is placed at the origin. Enga vechirukom, we have kept at the origin. Work done in taking another charge minus capital Q from the point A. Point A coordinates are 0, A, which means it is on the y axis, to another point B. Other coordinates are A, 0, which is on the x axis, along the straight path AB. First நம்ம அந்த diagram represent பண்ணி பார்க்கலாம். Okay, so we are keeping a charge plus Q in the origin, we are keeping a charge. Okay va? And a charge minus Q is moved. Angle and the point A and the point A is having what coordinates? 0, A. It is on the y axis. Angle and the, we are moving it to a point on the x axis. Apdi straight line AB. And the line we move pannirukom. Okay. What are the coordinates of the point B? A, 0. This is on the x axis. Okay. We have to find what? Work done in taking this minus Q. The A and B get எடுத்துட்டு போறதுக்கு, they are asking what is the work to be done. இங்க என்ன தெரியுமா, they have not even mentioned about any the velocity பத்தி இல்லனா kinetic energy பத்தி mention பண்ணல, which means what? We have to assume that initially நம்ம மூவ் பண்ண சார்ஜ் என்னது minus Q தானா. Initially we have to assume it is at rest, and the மாதிரி finally also we have to assume that is at rest, which means what? If you want to calculate what is the work done by the external force, அதுக்கு formula என்ன தெரியுமா? What is the charge we are moving? Minus Q dana. What is the charge we are moving? Minus Q. Minus Q into delta V. Minus Q. Delta V ensonna enadi? VB minus VA. So, and the A ketagatom or the B. Angle in the vardu, where the electric potential is coming from? It is coming from the charge which you are keeping at the origin dana. So point A ketagatom or point B. Where is the electric potential coming from? It is coming because of the charge kept at the origin dana. Inga parunga, what is the distance from origin to the point A? Small a. So potential enna theriyuma, what is the potential at the point A? KQ by A, avladha. Origin landu what is the distance to the point B? Adiyum A da, small a. A na, what are the coordinates? A, 0. If I say that there is a point 4, 0 on the x axis, origin landu what is the distance of the point? 4 units dana. So what will be the potential at the point B paranga? K into Q by distance from origin to point B. Enadi small a dana, which means what? VA oda value is equal to VB. Adanala potential difference will be what? 0. Potential difference 0 means work done minus Q charge point A and the point B kitta eduthu poradhukku, what is the work to be done? It will be what? 0. Ingona enna theriyuma, when we talk about this work done, it's not going to depend upon the path mele depend agadu. Enna, because we are only looking at what? Initial point and final point, right? We are looking at what is the initial point? It depends upon the locations. Okay va? So instead of taking along the straight line, they ask one more thing, like, they'll say, what if I take in a different path? In the மாதிரி ஒரு random path கொடுத்திருக்காங்க வெச்சுக்கோங்க. அதுவும் எப்படிதான், path does not matter here. What is the initial point, what is the final point, அவ்வளவுதான். Okay, so what is the work done in this case? It will be what? 0. Another it will be what? 0. These are another important result. Potential due to a uniformly charged ring. Ring another, we'll consider that the charge is only on that the circumference or that perimeter மேல இருக்கிற மாதிரி. Okay va? So we are giving a charge q to the ring which is uniformly distributed. Okay va? And the perimeter மேல it is uniformly distributed, which means the linear charge density, அதாவது தெரியுமா, what will be the linear charge density? Charge q divided by perimeter. If you take capillary as the radius of the ring, what will be the perimeter? 2 pi r dana. This is the linear charge density. Okay, so we will look at what is the electric potential due to the ring at a point on its axis. Inga we'll mark a point on the axis. This is the axis, right? The axis mela we'll mark a point at a distance small r. Okay, so point at a distance small r from the center of the ring. Center of the ring, we are marking a point in every distance r, small r. Okay, so we have to try and do it by using the integration approach. So we'll take a small portion in the charge dq, very small charge. Angalandi, if you look at it, right, what will be the distance to this point? Now mark panna point p. What is the distance? This is what radius of the ring. This is small r. Axis will be what? Perpendicular to the plane of the ring, which means this is 90 degrees. Appanna theriyuma idu right angle triangle madri. Idu d nu vechukonga. You know what is the d going to be? Hypotenuse, root of r square plus small r square. Okay, so because of the small charge, potential dv will be equal to what? Another it will be equal to what? K into dq by distance another root of capital R square plus small r square. Potential is a scalar quantity dana. இப்போ இங்க dq இல்லாம you take a dq some other place. இங்க ஒரு நீங்க dq எடுத்து பாருங்க. அங்கல இருந்து அப்படிதானா? What is the distance from that dq to the point p? Same, root of capital R square plus small r square. நம்ம எங்க ஒரு charge or a portion எடுத்தாலுமே we are going to have what? Same distance from that charge portion to the point, which means நமக்கு இதுல இருந்து we require total potential means அப்படியே இந்த வேல்யூ நம்ம இன்டிகிரேட் பண்ணனும், அவ்வளவுதான். அப்படியே நம்ம இந்த வேல்யூ இன்டிகிரேட் பண்ணனும். இதுல இருந்து தெரியுமா, k is a constant, the denominator ல இருக்கிற root of r square plus small r square அதுவும் கான்ஸ்டன்ட் தான், அப்படியே வெளிய வரும். k by root of r square plus small r square integral dq. integral dq என்னது? நம்ம ரிங் மேல இருக்கிற எல்லா சார்ஜஸ் நம்ம ஆட் பண்ணிட்டே போணும். dq 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 எல்லாம் ஆட் பண்ணனா வரும் capital Q, I mean the total charge தானா, which means what? The electric potential at the point p, அதோட வேல்யூ என்ன பாருங்க, kq by integral dq will be what? Total charge on the ring q, kq by root of capital R square plus small r square. K க்கு பதிலா we can write it as what? 1 by 4 pi epsilon naught. So what is the electric potential at a point on the axis of the ring? இது ஒரு ஸ்டாண்டர்ட் ஃபார்முலா, இது நம்ம கண்டிப்பா ஞாபகம் வச்சுக்கணும். ஏன்னா because sometimes அப்படியே அந்த ஃபார்முலா பேஸ் பண்ணி நமக்கு क्वेश्चंस வரலாம். We can expect some questions based on the straight as it is in the formula based பண்ணி. என்னது? What is the electric potential formula? It will be what? kq by root of capital R square plus small r square. Okay, or we can write it as what? 1 by 4 pi epsilon naught q by root of capital R plus small r square. இதுல என்ன தெரியுமா, observe one thing, நாம அந்த ring exact centerல இருக்கிற வெச்சுக்கோங்க. If you are exactly at the center of the ring, if you are exactly at the center of the ring, அப்ப என்ன தெரியுமா, smaller will be 0. ஏன்னா smaller is what? Distance of the point from center of the ring, which is 0. இப்போ smaller நம்ம 0 substitute பண்ண பாருங்க, smaller is 0 means what you are going to get? Root of capital R square, which is what? R. So potential will be what? You know, q by 4 pi epsilon naught into capital R. So as we move away from the center of the ring la irundhu நம்ம away move பண்ணா what is going to happen? என்ன ஆகும் பாருங்க, denominatorல பாருங்க, what is there? Root of capital R plus small r square, right? Which means what? If you move away, center la irundhu நம்ம away move பண்ணா smaller value will keep increasing. Smaller increasing means what? Denominator value is increasing means the total potential value will be what? Decreasing. Total potential value will be what? Decreasing. இது எப்படி தெரியுமா? It will not decrease like a straight line மாதிரி கிடையாது. It will be like what? Exponential decrease. இங்க பாருங்க. So this is where we have r is equal to smaller value is 0. Smaller value is what? 0. Okay. So that is where you will have the potential to be maximum. Another q by 4 pi epsilon naught into capital R. Another maximum value. This is the maximum value. What is it? Q by 4 pi epsilon naught into capital R. அதுக்கப்புறம் if you increase the smaller value means அப்படியே potential decrease ஆயிட்டு போகும். So when smaller goes to infinity, right? பாருங்க, when smaller goes to infinity, denominator is infinity means what? The potential approaches to 0. So it goes on decreasing, exponentially it will decrease, and as smaller goes to infinity, the potential will become what? 0. இந்த பக்கம் மூவ் பண்ணா அப்படிதான் ரிசல்ட் வரும். If you move in that side, center of the ring la irundhu, if you move that side means that will also same symmetrical da varum. Okay, so whatever the graph you have this side, other side also will have the same graph. Okay, so idhula rendu important terms enna theriyuma? One, the expression. What is the expression? Kq by root of capital R square plus small r square. Adu onnu. Rendavathu, the variation. Yen ipo neenga recent years la pathina we are getting lot of questions on the graph analysis. Adanal we should try to focus on இப்போ எந்த ஒரு எக்ஸ்பிரஷன் நம்ம கிட்ட இருந்து வச்சுக்கோங்க, அந்த எக்ஸ்பிரஷன் எப்படி கிராஃபிக்கலி நம்ம ரெப்ரசென்ட் பண்ணணும் அண்ட் ஹவு டு அனலைஸ் தி கிராஃப், அந்த மாதிரி ஒரு மாடல் ஆஃப் கொஸ்டின்ஸ்க்கு நம்ம ரெடியாக இருக்கணும். ஓகேவா? ஸோ இப்படி இருக்கும், லைக் ஆர் இஸ் ஈக்குவல் டு 0ல we'll have the maximum value for the potential. R ஓட வேல்யூ ஸ்மாலரோட வேல்யூ இன்க்ரீஸ் ஆகிட்டே போனால் then what is going to happen to the potential? Potential will keep decreasing, it will become finally 0 when smaller is approaching to infinity. Okay, இந்த பக்கம் அப்படிதான். Other side also if you move in same phenomena, exactly symmetrical varum. Okay, so this is how the potential due to a uniformly charged ring will be calculated. Okay, idhula nariya pannalam, yen theriyuma? We can also ask potential at a general point due to a ring, because of the ring, right? Somebody can ask what is the potential at a point P. Ingayadhu ஒரு point எடுத்துட்டு they can even ask potential at a point. Okay, but அந்த மாதிரி questions நீட்ல வரதுக்கு the chance are very very less. Okay, so இதென்ன, it's a standard arrangement of the charge. You have a charged ring, uniformly charged, because of the ring potential on the axial line or axis of the ring. It's a very standard situation. That is why we can expect some questions on this. Okay, அந்த மாதிரி situations, right? Like general point or idhula asking us to find the electric potential, அந்த மாதிரி questions வரதுக்கு the chances will be very much limited. Okay va? So this is about the potential due to a charged ring. Okay, so what we'll do is in the next session we'll continue with our discussion on the electric potential. Idhula nariya irukka, we have to discuss some more things about electric potential. Adukaprom we'll have to talk about the relation between electric potential and electric field, and we'll also talk about the electric potential because of the distributed charges. Like in the field case we discussed about it, right? Because of the distributed charge, we tried finding what is the electric field by using the Gauss law concept. And the we'll try to find what is the electric potential because of the distributed charges. Okay, so we'll continue our discussion in the next session.